Okay, in this video we're going to explore compounds, molecules that have what we call multiple bonds. Multiple bonds meaning not just a lot of single bonds, but having double or triple bonds. Those we classify as multiple bonds. Okay? And now, how does that happen? That occurs when, as we do our NASB method, we come up with a number. Let's say, as we're probably going to do in this one, we're going to come up with a number of 4. But when we have gone in following our steps and put a single bond into everything, we have not used 4. That means we've got to go back and assign another bond in there somewhere, a multiple bond, either a double or triple, depending on how many we've got to assign. And we can only assign that to specific elements. Hopefully you've got those memorized now. Nitrogen, carbon, oxygen, sulfur, and silicon sometimes. Okay, so N, C, O, S, and Si. Those are the ones that we can do. So here's our compound. We're going to kind of step through this step by step. COCl2. All right, COCl2. So let's talk about needed. First thing, any hydrogen in that compound or in that molecule? The answer is no. So we know that every atom in there needs 8 electrons. We've got 1 carbon, 1 oxygen, and 2 chlorines. So I have 4 atoms, each of which needs 8 electrons. All right, 8 electrons. So we need 32 electrons if everybody was going to be very happy here. All right, available. Let's see. We've got, 1 carbon. We've used that a lot, so everybody by now knows that that's got 4 electrons in its valence count. We've got 1 oxygen, and I have to kind of write that out so it doesn't look like 10. 1 oxygen sitting in group 6, so it brings 6 valence electrons with it. All right, and I have 2 chlorines, and they're in group 7, so each of them is bringing 7 electrons. 2 times 7 is 14, plus 6 is 20, plus 4 is 24 electrons available. All right, shared, N minus A again, 32 minus 24 says I'm sharing 8 electrons, and bonds is shared divided by 2. So again, 8 divided by 2 says I need 4 bonds to show in this compound. All right, central atom. Well, let's see. 2 chlorines, they're probably not going to be there because there's 2 of them and they're halogens. So that leaves carbon and oxygen. There's 1 of each. But go back to your electronegativity trend and look at carbon and oxygen. They're in the same period, but carbon is farther to the left, farther away from fluorine, so it is less electronegative than oxygen, and carbon likes to be in the center, so I'm going to choose carbon as my central atom. All right, so I'm going to come over here and I'm going to put carbon in the center. I'm going to put what? I'm going to put oxygen somewhere. I'm going to put a chlorine, and I'm going to put another chlorine. Now, remember, 3 things. The easiest way to get them apart is probably in some kind of 120-degree angle from each other, or in a kind of a triangle shape. All right, so I've put my central atom in. I've put my other atoms, my other 3, the 1 oxygen and the 2 chlorines around it. And at this point, I'm going to draw a single bond to everybody. All right, I've put in 3 bonds, but this says I need 4 bonds in this compound. I need a 4th bond. All right, so that means I'm going to have a multiple bond somewhere. And this is why you need to remember which atoms can have multiple bonds. Halogens do not have multiple bonds, so that leaves out the chlorines, but carbon and oxygen are 2 of those that can form multiple bonds, so I'm going to put my other bond right there. All right, I'm going to put my other bond right there, and now I'm going to go in here then, and so bonds are taken care of now. I've put in 4, I had to put in 4. Now I'm going to assign my available electrons, starting on my outside elements to make sure everybody out there has 8. This chlorine at the top already has 2 in that bond, so it needs 6 more, so I'm going to give it 6 more electrons. This chlorine already has 2 from that bond, so I'm going to give it 6 more. All right. Now watch this. Oxygen already has 4 assigned to it because it has 2 in that bond and 2 in that bond, so it already has 4, so it only needs 4 more. So I'm going to give it 4 more. All right. Now I'm going to count. Everybody on the outside has an octet, so let's count. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I've used all 24 electrons. Now, does everybody have 8? That chlorine has its 8. That chlorine has its 8. That oxygen has its 8. And carbon has 8. It's got 2 in the single bond to chlorine, 2 in that single bond to chlorine, and 4 more in that double bond to oxygen. So it has 8 electrons also. Everybody's happy. Give yourself a big check mark for having the right Lewis dot structure for that compound. All right. The one I need you to practice on would be the famous carbon dioxide molecule, CO2. I want you to, again, like we've been doing, put this on pause, go through your NASB, choose your central atom, put on all your bonds, assign your available electrons, double check to make sure everybody has 8 electrons if it needs it, or 2 if it's hydrogen, and then we'll see what you have. So put this on pause, do your structure, and then we'll pull up the structure I've drawn. All right, here's my structure for CO2. All right. Let's just go through my math here. Let's look at what I did. I'm going to just change colors real quick. All right. Needed was 24 because I had 3 atoms, a carbon and 2 oxygen, each needing 8. That's 24. Available was 16, right? Carbon had 4 and each of the oxygens had 6. 24 minus 16 is 8. 8 divided by 2 says I need to show 4 bonds when I drew this. Pretty easy to pick the central atom. Got to be carbon for at least 2 reasons. It's the least electronegative of the atoms there, and it is carbon, and it likes to be in the center. So I drew my carbon in the center. I put the oxygens 180 degrees apart. I drew in a single bond. That's what you see in green, which means I put in 2 bonds to start with, right? Because our rule says after you draw the outside elements, draw a single bond to it. All right, I put in 2, but this thing said I needed to show 4, so that's why you see the 2 additional ones in blue here. And I decided to put 1 on either side. All right, and then I had to go back and start assigning my 16 available electrons, starting with my oxygens on the outside first. The oxygen on the left had 4 electrons in that double bond, so it needed 4 more, so I gave it 4 more. The oxygen on the right had 4 electrons in that double bond, so it needed 4 more, so I assigned it. And so now the oxygens each have 8, so I'm going to count how many I've used. 2, 4, 6, 8 for that oxygen there. 2, 4, 6, 8 there, so that's 16 electrons assigned. And I needed to only show 16, so that's good. Does everybody have 8? The check is yes. Each oxygen has 8. And the carbon has 4 bonds around it, each containing 2 electrons, so it has 8 electrons. Now, you may have come up with a slightly different compound, okay? You may have a slightly different drawing. You may have done this. You may have said, okay, let's put the carbon there, let's put the oxygen there and the oxygen there, and we'll put a single bond to each. And then you may have said, I've used 2, but I need to use 4. You could have put in the other 2 on one of the atoms, and then gone back and assigned your 16 electrons. This oxygen only has 2, so it needs 6 more. All right. This oxygen has what? 2, 4, 6. It already has 6 in that triple bond. That's what a triple bond looks like. So it only needs 2 more to get 8. And then I'll do my count. 2, 4, 6, 8, 10, 12, 14, 16. So I've again assigned 16 electrons. Everybody has 8. The oxygen on the left-hand side has a single bond and 6 electrons, 6 unbonded electrons. The oxygen on the right has a triple bond for 6 electrons and a pair of electrons that are unbonded, so that's 8. And the carbon has 4 bonds around it again, a single bond and a triple bond. So it has 8 also. So that is a possible structure. The reason I think this is probably the better structure is it's more symmetrical. 2 double bonds, one on either side, is more symmetrical than a single or a triple. Would I count this one wrong if you drew this one here? No, I wouldn't, because it follows the rules. It meets all of our criteria. You've got everything put in right. You haven't put in more electrons than are there. You haven't put in more or fewer bonds than you needed. So I would give you credit for that. I'd probably, on your paper, I might draw that one there and say this might be a better structure. All right, folks, that's the end of this little video. So hopefully you can do the Lewis dot structures for compounds that are going to contain multiple bonds. But again, remember, our key is after we put the central atom in, we put a single bond to every other element that is around it, and then we compare how many bonds we've used to how many bonds need to be in that structure. And if we have not exceeded the bond count here, we need to at least get that number of bonds in our structure. And so that may take double or triple bonding. All right, that's going to end this video. You're encouraged to continue to practice this, and if you need to go on and look at some of these others about extra available electrons, compounds that violate the octet rule, ions, any of those that you haven't already looked at, please do so as you need.